Hello everyone and welcome. In this video we're going to compute the integral from 0 to 2 pi of 1 over gamma of 1 minus e to the I theta d theta. Let's denote it by I. So we see here that this integral is improper at 0 and at 2 pi because it's 2 pi periodic, so that kind of makes sense. So in order to compute it, we're going to make a change of variable to turn it into a path integral. Then we're going to use Cauchy's integral formula. Okay, let's get started. So we are going to set z equals e to the I theta, so that d theta is equal to dz over iz. Now as theta runs from 0 to 2 pi, well, z is going to run on the unit circle. So now our integral becomes the integral along the unit circle of 1 over iz times gamma of 1 minus z dz. So here we see that we have a little problem. We have a singularity on the path of integration at z equals 1. So we have to avoid that singularity. In order to avoid it, we're going to multiply and divide by gamma of z and then use Euler's reflection formula. So let's multiply and divide by gamma of z. Now let's recall Euler's reflection formula. So it tells you that gamma of z times gamma of 1 minus z is equal to pi over sine of pi z, as long as z is not an integer. Now if we replace, we're going to get, and after simplifying, we're going to get that I is equal to the integral along the unit circle of gamma of z times sine of pi z over I pi z. Now we have a product of two functions. Now the quotient sine of pi z over I pi z has no singularity. In fact, we can simply extend it by continuity at z equals 0. Okay, so we can see that simply by looking at the limits. So the limit of sine of pi z over pi z as z tends to 0 is equal to 1. But the limit of gamma of z at z tends to 0 is infinity. However, if we look at the product, z times gamma of z, it is equal to gamma of z plus 1. So if we take the limit of z times gamma of z at z tends to 0, we're going to get gamma of 1, which is 1. So we have a simple pole at z equals 0 for the gamma function. Now, because of that simple pole, if you apply the residue theorem or Cauchy's integral formula, we're going to get that I is equal to 2 pi I times the residue of the integrand at z equals 0. Now, because we have a simple pole to get the residue, all we have to do is multiply the integrand by z and then take the limit as z tends to 0. Okay? Now, z times gamma of z is equal to gamma of z plus 1. So we just replace that. And then we take the limit. Now, the last term, which is sine of pi z over pi z, tends to 1 as z tends to 0. And gamma of z plus 1 tends to gamma of 1 as z tends to 0. So we get 2 pi times gamma of 1 times 1. But gamma of 1 is just 1, so we get exactly 2 pi. And this is a good place to stop. Thank you for watching and see you next time. Bye.